All right, ladies and gentlemen, in this video, we will be using page 52 of our notebook, and our objective will be that we will be factoring the difference of two perfect squares. Now, before we do that, I need you to recall and remember some information. One thing that makes learning powerful is if we can take some old information, things that we've already learned, like multiplying two binomials, and link it together with some new concepts that we're going to learn today, which is the factoring of the difference of two perfect squares. So you will either right now need to pause the video and get a separate sheet of paper, or if you're on your notebook, if you look at the bottom of page 51, there's a big open space. You can write this information there. But I want you to take and write down problem 1 and problem 2. And I want you to multiply those two binomials, how you've done in previous weeks. If you are someone that switches between the claw method and the box method, please multiply these using the box method. It's going to be able to make sure that we see the connection a little better if we use that method. So go ahead and pause the video, write these two down, and multiply them. When you have your answers done, go ahead and restart the video. All right, so let's check and see what you have done with your multiplication of two binomials. So if we have used the box method here, we have a binomial x plus 3 times a binomial x minus 3. And remember that it doesn't matter. I wrote this polynomial on the vertical and this polynomial on the horizontal, and you could have those switched around and still get the same result. Okay, so when I go to multiply, I take and say that this x times x would get me x squared. X times negative 3 is negative 3x. 3 times x is a positive 3x. 3 times a negative 3 is a negative 9. And when we go to combine like terms, we're going to see that we have an x squared. But then what happens here is that we have a positive 3x and a negative 3x. And those two terms are going to cancel out, and we're going to be left with a minus 9. Now, before we go to the next problem and check our multiplication, I want you to look at the original problem here. See if there's anything that you notice. And hopefully what you do notice is that in our binomial, in the first position there, that we both have the same term, an x. And then in the last position, we both of those have the same constant, 3. And what is different between these two original binomials is that one of them has a plus sign and one of those has a minus sign. So I want us to notice that, and I want you to look then as we look at our second problem over here and see if it falls into the same format. So if we look at this, do you see how that 4x, the first term, is the same? That we have a 3 and a 3, and what is different is that one of these have a plus sign and one of these have a minus sign. And so this is going to be a pattern that we're going to look for. Before we do that, I want us to take and multiply this out again and see what happens. So you've probably already multiplied this out on your paper. Just check along with me. Here's my 4x plus 3 and my 4x minus 3. And so when I multiply 4x times 4x, I'm going to have 16x squared. 4x times a negative 3 will give me negative 12x. Positive 3 times 4x will give me positive 12x. And then 3 times a negative 3 will give me negative 9. So let's take and combine like terms here. if we look at this, we're going to take and say that here is 16x squared. There's no other squared term to combine with. But then I'm going to combine these, and the positive 12x and the negative 12x are going to cancel out. And then we're just going to have the constant minus 9. I want us now to look at our answers. So we have a answer here, a product, and an answer here. What I want you to notice is that in both of these problems, we ended up with a binomial as our answer. And we did so because these middle terms canceled out. Even further, what we have found is that these answers contain perfect squares. We reviewed perfect squares last week. If you look at this, x squared is a perfect square. Then we have a minus sign, and 9 is a perfect square. 16x squared is a perfect square. We have a minus sign, and then 9 is a perfect square. This is going to be our goal for today. We are now actually going to be starting with these as our problem, and we will need to work backwards to get to our factors as the answer. But by looking for the patterns that we just talked about here, that's going to make it a little bit easier for us. You can see that why this is called a difference of two perfect squares. Because it's exactly what the wording means. Difference is subtraction sign of two perfect squares. Perfect square, subtraction sign, perfect square. Okay, so we're going to see that how this factoring of the difference of two perfect squares links very closely with the multiplying. Okay, so we're going to start this by looking at the examples now on page 52. I'm going to be following the exact 6 answers that are on page 52. I'm just not using the worksheet as a background. So if you look at page 52, these would be the first 3 problems. Okay, so our goal now with this is to be able to factor. And what that means is that we want to break it down into its parts, and we want to look for the types of factoring that we've already discussed. So when we think about that, the first thing I want you to think about is, does this problem, number 1, have a greatest common factor? So if we look at it between 4x squared and 9, there is not a greatest common factor. Now, the only other type of factoring that we've talked about so far is grouping. And grouping has to have 4 terms. And so it is obviously doesn't have 4 terms, so it's not a grouping problem. So the next thing I'm going to look for is that I'm going to look to see if this is what we call a difference of 2 perfect squares. And you can see how I abbreviated that just so we don't have to write it out every time. D for difference, 2 perfect squares, PS. Okay, so when I look at this, I can see that I have 4x squared minus 9. Both 4 and the x squared and the 9 are all perfect squares. So I'm going to use what I've learned with my multiplication. And I know that the 4x squared would be here, and the minus 9 would be here. So if I think about either what is the square root of 4x squared, or what times what gives me 4x squared. What that is 2x times 2x. And then I think, well, what would give me a minus 9? And the minus 9 would be from a positive 3 and a negative 3. If I filled in the remaining things here, what would happen is that this would be a negative 6x and this would be a positive 6x. And these two terms would end up canceling out. And so what that tells me is that my factors then are going to be 2x plus 3 times 2x minus 3. So I took this difference of two perfect squares, because we have a perfect square, a minus sign, and a perfect square. And I took that and I broke it down into its two factors, using what I know about the box method and multiplication to be able to get my answers. Now, some people may very quickly see the pattern and think, I don't need that box method to help me do that. I'm able to do that on my own, and skip that and just go straight to the answer. And whenever you feel comfortable, go ahead and do that. And you can, if you feel like the box always helps you visualize, you can always use the box. So I'm going to look at my next one here. I always look and say, well, start with, is there a greatest common factor? 25x squared minus 49, there is not. So that's out. Grouping, it doesn't have four terms, that's out. So I'm going to look for, is it a difference of two perfect squares? So what I'm asking myself is this a perfect square? Is this a minus sign? And is this a perfect square? Now, if I recognize that yes, it is, then I may immediately go to my answer and say, well, I know that 25x squared is 5x times 5x. And that a negative 49 has to be a positive 7 and a negative 7. And I could have my factors immediately. Or I could think through the problem and say, well, if this is 25x squared minus 49, I know that 25x squared would, the square root of that would be 5x times 5x. And I know that a negative 49 is a positive 7 and a negative 7. And what would happen is that this would be a negative 35x and a positive 35x, and they would end up canceling each other out. And I want us to keep in mind that in both of these final answers, I happen to write the factor with the plus sign first, but keep in mind that this would be the exact same answer, that the order in which I multiply those two factors together doesn't matter. Now, I'm not going to write down both answers for both of those. I just want you to make, for all of them, I just want to make sure that you know that that means exactly the same thing. You know, if you think to a very basic type of example, if I say, well, what's 2 times 3? You know that that's 6. If I say, what's 3 times 2? If I switch that order, the commutative property says, hey, the answer's still 6. So the same thing holds true with these factors, that the order of which I have the positive factor and then the one with the negative sign doesn't matter when we multiply those out. Okay, so let's look at the next one. We want to kind of develop a thinking in our head here. So I look at a 100x squared minus 1. I think about, is there a GCF? There's not. I think about, are there 4 terms? There's not. So then I think, does this meet the pattern of a difference of two perfect squares? Is this a perfect square? Is this a minus sign? Is this a perfect square? And if you see the pattern, then you're immediately going to go to the answer and say, I know that 100x squared, that is 10x times 10x. And I know that 1 is a perfect square, and that is a plus 1 and a minus 1. If you need to visualize and want to use the box to help your thinking, you would start by saying, well, this is 100x squared, and this is a negative 1. So I know that my 100x squared is 10x and 10x. And I know that 1 can only be 1 times 1. And for it to be a negative 1, that must be a negative 1 and a positive 1. And what would happen then with our middle two terms is that we would have a positive 10x and a negative 10x, and they would end up canceling out. And once again, I would know that if I wrote my answer as 10x minus 1 and 10x plus 1, that these two answers here are exactly the same thing. You don't need to have both of those. One of those is sufficient, just showing you where they both come from. Okay? All right, so let's look at problems 4, 5, and 6. So if we look at problem 4, first thing I ask myself is there a greatest common factor? And actually with this problem, we start to see that there is a greatest common factor. So the GCF here is a 4. And so I'm going to take and factor out a 4 out of each of these terms. And what that will leave me with is a 1x squared minus 4. Now, what I'm going to do is I'm immediately going to drop down to the bottom, and I'm going to put that 4 out in front so that I don't forget it. And now I'm going to look just at this part of the problem, the x squared minus 4, and see if that factors any further. And hopefully what I notice is that this is a perfect square, a minus sign, and a perfect square. And so what that means is that this x squared comes from multiplying x times x, and this 4 comes from multiplying 2 times 2, and for it to be a negative 4, I would need 1 positive and 1 negative. If I wanted to use the box to help with my thinking, that's perfectly fine. The x squared and the negative 4. The x squared is x times x. The 4 is a positive 2 and a negative 2. And what would happen is that our middle terms would be a positive 2x and a negative 2x, and they would cancel out. So that you can see in this particular problem, we used two types of factoring. We used a greatest common factor, and then we used a difference of two perfect squares. And we're going to start to see that more often, that we have greatest common factor and another type of factoring within the same problem. So we have to check it all the time, but it might not show up in every single problem, but we do have to look for it. Okay? If I look at the next problem here, I can see that if I'm looking for a GCF, there is not a GCF. And so then I look at it, there are not 4 terms, so I can't do grouping. So it's a binomial. The only other thing I have for a pattern for a binomial is this a perfect square minus a perfect square? And it is. So if you notice it, then boom, you can go straight to the answer. X squared is x times x. To make a negative 1, you would need a positive 1 and a negative 1. And there are 2 factors. Or if you'd like, you can use your box and think, well, hey, this was an x squared and this was a negative 1. The box just helps us think through the process. The x squared is x times x. The 1 is a 1 times 1, and for it to be a negative 1, I need there to be a negative and a positive. And you could see how then that would give us those two factors as our answer. Okay. If we look at number 6, a type of problem like number 6 is often missed, and students will write that it cannot factor because they look at this original problem and they look at it and say, well, perfect square minus perfect square, 8 is not a perfect square, 50 is not a perfect square, I can't factor this problem. But what is actually happening is that in this problem, there is a GCF that we need to take out first. And so our GCF here is going to be 2. So if I take and I factor out a 2, I'm left with 4x squared minus 25. Now, some problems only have a greatest common factor. That's all you can do, and then you stop. But I always have to check, can this, what's inside these parentheses, can this part go any further? Does this meet perfect square minus perfect square? And if I know my perfect squares 4 and 25, I see that they are. So I immediately take and say, well, I'm going to drop down this 2, so it becomes that greatest common factor has to be part of my answer. I'm going to draw my parentheses. And then you're going to decide, whether or not you want to use the box or not. If we look here, this 4x squared is 2x times 2x. And then the 25, a minus 25, minus 5, and plus 5. And then keep in mind that if the box helps you think through the problem, please continue to do that. It's going to help us next week with our next type of factoring as well. So if I look at 4x squared and a minus 25, the 4x squared will be 2x and 2x. And then the 25 would be 5 times 5. And it's a negative 25, so I need 1 negative and 1 positive. And then what would happen is that we would have a positive 10x and a negative 10x that would end up canceling out.